Hello and welcome to today's presentation on communication between components. In this session, we will explore the different types of communication methods used in distributed systems, including synchronous and asynchronous communication, and look at communication protocols such as REST APIs, gRPC, and messaging queues. Communication between components is a critical part of designing scalable and efficient distributed systems. The main types of communication we will focus on are synchronous and asynchronous communication. Additionally, we will discuss key technologies such as REST APIs, gRPC, and messaging queues, all of which play a vital role in how components interact with one another. Let's dive into the two main types of communication, synchronous and asynchronous. In synchronous communication, the sender waits for a response from the receiver before continuing with the process. This type is ideal when im- immediate feedback is required, but it can create issues if the receiver is slow or unavailable, as it blocks further operations. On the other hand, asynchronous communication allows the sender to continue without waiting for a response. This approach is non-blocking and highly scalable, making it well suited for tasks that don't require immediate responses like event-driven systems or background tasks. Now, when deciding between synchronous and asynchronous communication, it's important to consider your system's needs. Use synchronous communication when immediate feedback is essential, like in real time applications where tasks must happen in a specific order. On the other hand, asynchronous communication is a better choice when scalability is a priority. It allows components to operate independently and can handle large volumes of messages without blocking the system. Next, let's talk about REST APIs, one of the most common communication methods used in web and mobile applications. REST stands for Representational State Transfer and it follows a stateless architectural style. Communication happens via standard HTTP methods such as GET, POST, PUT, and DELETE, with data typically exchanged in JSON or XML formats. Another popular communication protocol is gRPC. Developed by Google, gRPC is a high performance remote procedure protocol (RPC) framework that uses HTTP2 for faster communication. What makes gRPC stand out of its use of protocol buffers for serialization, which is highly efficient and strongly typed. gRPC also supports bidirectional streaming, enabling real-time communication between services. This makes gRPC an ideal choice for microservices architectures or applications that require low latency and high throughput, like chat applications or live data feeds. Messaging queues play an important role in asynchronous communication by allowing components to communicate through queues without needing to be directly connected. Two common messaging queues are Kafka and RabbitMQ. Kafka is designed for high throughput data streaming and real time analytics, while RabbitMQ is a message broker that supports various protocols including AMQP. When deciding on a communication protocol for our system, several factors come into play. If real time processing is essential, protocols like gRPC might be the best choice. For simpler web-based interactions, REST APIs are often preferred. On the other hand, if we need decoupling and asynchronous message processing, a messaging queue like RabbitMQ or Kafka might be the best solution. Effective failure handling is essential in any distributed system. Let's look at a few strategies. First, timeouts can be used to handle delays in communication, triggering retries or providing failure responses when a service is unavailable. Automatic retries can help ensure that requests are retried if they fail temporarily. The circuit breaker pattern helps prevent repeated failed requests to an already failing services. With dead letter queues, store failed messages for investigation and further action. In conclusion, communication between components is crucial for the proper functioning of distributed systems. Choosing between synchronous and asynchronous communication depends on factors like performance needs, and system scalability. Using REST APIs, gRPC, and messaging queues can help meet different communication requirements. Additionally, implementing failure handling mechanisms like retries and circuit breakers ensures that the system remains resilient and reliable. Thank you for your attention. I hope this session will provide valuable insights into the communication strategies used in distributed systems. If you have any questions or need further clarification, feel free to ask.